Hello, everyone, and happy holidays. I'm Divya Bharghov, Senior Engineering Director of Greenplum. We released Greenplum 623 this week, and I'm here to talk through some highlights about this release. We added a new option while creating or altering tables. I want to quickly provide some context so that this jargon we're using here in this slide becomes clearer. So let me first talk about table partitioning. Table partitioning enables supporting very large tables by logically dividing them into smaller, more manageable pieces. Partition tables can improve query performance by allowing the Greenplum Database query optimizer to scan only the data that's needed to satisfy a given query instead of scanning all the contents of the large file. For example, let's say there's some sales data that's partitioned by month. You can quickly generate reports about last month's sales by not having to run through everything from the past. Now, this is table partitioning. Now I'm going to touch upon what is statistics and the analyze commands. Statistics are metadata that describes the data stored in the database. So this basically helps your query optimizer to choose the best execution plan for the query. For example, if a query, let's say, joins two tables and one of them must be broadcast to all other segments, the optimizer, based on the metadata, on the size of the tables or the number of rows, it can make a decision on which among the two tables it should broadcast. Obviously, it can choose the smaller one so that it can minimize the network traffic. Now, in the database, these statistics are generated using the Analyse command. When you run the Analyse command, all these statistics are generated and stored in a system table. And analyzing large tables is generally an expensive operation, usually done during maintenance windows and things like that. Now, for partition tables, Analyse collects additional statistics. These are the HLL statistics or the hyperlog log statistics on the leaf partitions, on the leaf child partitions. Now, this is used to derive the number of distinct values for queries against the partition table. Now, however, in many situations, the partition table changes, right? We constantly add new partitions into an existing partition table. And that could be like a regular table that you're trying to add, or you could exchange a partition. In this example, I'm trying to add December in an existing partition table. And by default, this table, December, does not have the HLL statistics that I mentioned. So when you bring this December as a part of this root table, it would need to be, since not all the leaf leaf partitions have the HLL statistics now, we will need to reanalyze the table and the root table as well. So with this limitation is overcome with this new option called Analyse HLL non-part table. With this, you can also collect stats for HLL stats for regular tables. So the typical use case for using this would be if you're planning on making a regular table a part of a partition table in anytime soon, you could use this option. All right, let's move on to the next feature. So this is a feature related to the CPU set. We already have the CPU set in resource group. So first, just a quick intro again. Resource groups help enforce CPU, memory, concurrent transaction limits in database. You can identify the CPU cores that you want to reserve for a given resource group with the CPU set property. So for instance, you can say, make sure that Greenplum database, right, like all these segments run on CPU cores 1 to 3, things like that. Now, previously, CPU set allowed a common setting for all segments as well as the master. We are increasingly seeing that the pattern of master host resource usage is quite different from that of the segments. So in this release, we introduced a different CPU set specification where you can different CPU core specification for master and segment hosts. For example, as you see here, if you give CPU set 1 semicolon 1 to 3, that means reserve core 1 for the master host, and on segment hosts reserve cores 1 to 3. A deeper dive into resource groups is available in the link provided here. It's a very difficult or rather interesting set of challenges. That is the concurrency. I strongly suggest you to run through some of the guides in this link. Let me next touch on some extensions we've added from Postgres ecosystem. First, the L tree or the label tree. We have a new data type named L tree that you can use to represent labels of data stored in a hierarchical tree-like structure. This also provides extensive facilities for searching through the label trees. Let me show you an example usage, which will make it clearer. So here's a table we created and called test, and the path column is of the type L tree. So this is what the tree looks like, and that's how we are representing it. So we can insert values like top science, top dot hobbies, top dot collections, and go on this way, as you see here. And you could create indexes. Now, after you've created it, of course, you could look it up and you could do some cool features like inheritance, right? So if you're looking at all the parts from this table where it's top.science, you get all the top.science, astronomy, astrophysics, cosmology. So all these rows come out. Or you could also do pattern matching. There's some examples here. So I'm doing astronomy. All the astronomy stars are coming out, even if it's from science or pictures or anything, right? So this is actually a really nice extension. And if you need to learn more about this extension, I have pasted the link here. You can visit that and look into the various options that are available with the extension. Okay, I'm trying to click here. All right. That's the next extension. It's a popular one to support nanoseconds. With the timestamp 9 extension that's added, Greenplum now provides nanosecond precision timestamp data type and related functions and operators. So to learn more about the various functions or operators, visit the link that I've pasted there. We have another extension, UUIDOSSP module, that helps generate UUIDs with one of the standard algorithms. See the example there, and for more information, again, visit the site pasted there. I actually feel really thankful that Greenplum is open source as well as based off Postgres. And we can make use of this rich Postgres ecosystem, Postgres features and extensions in a massively parallel fashion. And a big thanks to the Postgres community for that. So to wrap up, this is the summary of the key features going in 623 that I discussed today. Apart from this, we have several performance and stability, support, diagnostic tooling improvements that we've put in. So I am really excited about this. So go try 623. Last but not the least, I want to mention that we've released GP7 beta this month, and looking forward to a grand Greenplum 7 release next year. Happy holidays, Merry Christmas, Happy New Year, and thank you.